Okay. Okay, so welcome everybody. It's good to see everybody back. I know we haven't had a lot of meetings in March and in April. There's been holidays, there's been sickness, there's been travel, but looking forward to meeting today, and I don't foresee any interruptions over the next few weeks. So we should be able to meet every week over the next few weeks. Um, so welcome everybody. I'm recording, so if you want to type your name in for attendance, I assume Sange is also keeping a record, but if you want to type your name into the chat, then we will definitely have your record for the attendance. Um, okay, so yeah, so I hope everybody's doing fine and everybody had a good 2 weeks and a good fast and prayer day last week, a meaningful day, and yeah, so I think we can go get started. So what I want to do today is kind of finish our study of trigonometry formulas, right? So today is going to be all about formulas, and then next time we're going to go back to like the geometric meaning of trigonometry and everything. So today is just going to be about formulas and equations, and then next time we're going to go see a little bit more about the law of sines and the law of cosines, and we're going to relate trigonometry back to triangles again. Okay, so as usual, I want to start out by going over these homework exercises, but maybe before we look at the exercises, let's just recall these formulas that we have for these addition and subtraction formulas that we did last time. And remember, this cosine of a minus b, which was cosine A cosine B plus sine A sine B. This one we proved using geometry. We actually had to draw a picture to do this proof. And we saw that we had one line segment and another line segment that were the same length. And by setting those lengths equal to each other, we were able to prove this equality over here. And once we had this one equality, what we then saw was that we could get everything else just from using the one equality. So we could substitute minus b for b, and that gave us the second equality. And then we were able to switch between sine and cosine. Remember what we did? We used that sine of theta is equal to cosine of 90 degrees minus theta. We use this many times. Okay, so we use this many times to do all of these other proofs. But now we have these four formulas, and I don't have a great way of memorizing them. What I remember is that cosine reverses the pluses and minuses. So a minus b goes to cos a cos b plus sine a sine b. So cosine reverses the pluses and minuses, and sine keeps the pluses and minuses. It doesn't reverse them. Minus still has a minus, and plus still has a plus. And then I remember that cosine keeps the cosines together and the sines together, whereas sine mixes the sines and the cosines. So it's sine A cosine B minus cosine A sine B. But I don't know how much easier remembering that is than just remembering these four facts. So I don't have a great trick to remembering all of these. But that's, if you want to know what I do in my head to remember them, this is what I do. I remember that cosine switches the pluses and minuses, and sine doesn't switch the pluses and minuses, and cosine keeps the trig functions together, and sine mixes them up. That's how I remember this. I don't rederive this every time I need to use it again. Okay, so here we have these formulas for sine and cosine of the sum of two angles and also for the difference of two angles. Okay, so let's go back to the homework over here. So the first homework question is, so we know how to do cosine and sine of 30 degrees and 45 degrees and 60 degrees, but usually we've not memorized how to do cosine of 15 degrees and sine of 15 degrees. So we want to evaluate this cosine of 15 and sine of 15 degrees by using the subtraction formula. Okay, so here's going to be cosine of 15 degrees, and this is going to be sine of 15 degrees. Okay, so if we're going to use the subtraction formula, how should we write 15 degrees as a minus b, where we know the angles a and b? So, because most people don't memorize cosine of 15 degrees. I haven't memorized cosine of 15 degrees. I don't know what it is. But I do know other angles whose difference is 15 degrees. So what could we use here for A and what could we use for B if we want A minus B to be 15 degrees?
60 and 45.
Yeah, so 60 and 45, that'll work, right? So 60 degrees minus 45 degrees. And now we can use the formula that we know. So remember, cosine is going to turn a minus into a plus in this formula. So that's cosine of 60 degrees times cosine of 45 degrees plus sine of 60 degrees sine of 45 degrees. And now these are quantities that we know, right? So what's cosine of 60 degrees?
1 or 2.
Right, so 1 over 2, and then cosine 45.
2 over 2.
Right, root 2 over 2, and then sine of 60.
1 over 2.
Careful,
Root
sine
3 over 2.
root 3
Root 3
over
over
2,
2.
right? Root 3 over 2, and sine of 45 is
Root 2 over 2.
exactly same as cosine of 45. So this becomes square root of 2 over 4 when I mix them up, plus square root of 6 over 4. So if I want to write a final answer, this is square root of 2 plus square root of 6 over 4. Okay. So that's cosine of 15 degrees. It's square root of 2 plus square root of 6 over 4. Okay, generally not something that I have memorized, but that's what it is. And if you want this in decimals, this is about equal to 0.966. Okay, so it's quite big. Okay, so any questions on this? Right, so this is pretty straightforward. We used 60 and 45. You could also have used 45 and 30. You'd end up with the same answer. Okay, so 45 and 30 would also work because 45 minus 30 is 15. Okay, so for sine, we'll do the same thing. So sine of 15 is sine of 60 degrees minus 45 degrees. And so here we get slightly different formula. Remember, we have sine of 60 cosine of 45. And now with sine, the minus stays a minus. So we subtract cosine of 60 degrees sine of 45 degrees. But the good news is we've already evaluated all of these over here. So we can just look at what we did. So sine of 60 was square root of 3 over 2. Cosine of 45 degrees was square root of 2 over 2. And then minus cosine of 60 degrees was 1/2. Sine of 45 degrees was square root of 2 over 2. And so what we end up with here is square root of 6 divided by 4 minus square root of 2 divided by 4. Okay. Oh, yeah. So I see Armstrong. I just see in the chat. What if we take 45 and 30? That'll work also. Maybe we should do it both ways, right? So let's just write over here. So this is square root of 6 minus, so I'm a little skeptical of this. It's square root of 2 plus square root of 6 over 4, square root of 2 minus square root of 6 over 4. It's going to be, should be right. Oh, squared. Okay, yeah, square root of 6 minus square root of 2 over 4. Okay. And so this should work. Okay. So Armstrong asks in the comments, what happens if we take 45 and 30? Well, let's just see, right? So we have a little bit of extra space here. So what happens over here if instead we do sine of 15 degrees equals sine of 45 degrees minus 30, right? I mean, this should still work. Yeah, I think this is the simplest form over here. Oh, sorry. Yeah, so square root of 2 plus square root of 6 over 4, or square root of 6 minus square root of 2 over 4. This is the simplest form. There's not really any simpler form that you can have. This is as simple as it's going to get. Okay.
But you can still give it as you can further simplify it.
How would you
By,
simplify this?
factoring out root 2.
Okay, I mean, is that simpler? I mean, okay, you could say this is square root of 2 times 1 plus square root of 3 over 2 over 4. Um,
Yeah,
yeah, I mean, I think it's in the eye of the beholder whether this is simpler or whether this is simpler, right?
yeah.
I mean, you can write it in either form, but I wouldn't say that one is simpler than the other. I think
So,
this is completely fine.
what do I say?
Yeah. Okay, maybe that's what he's saying. Okay. So what happens if we do this? Sine 45 minus sine of 30. Well, we use the same formulas. So that's going to be sine 45 times cosine 30 minus uh, cosine 45 sine of 30. Sorry, the writing is a little small. And that's going to turn out to be square root of 2 over 2 times cosine 30, which is square root of 3 over 2, minus cosine 45 is square root of 2 over 2 times sine 30, which is 1/2. And again, you see we get exactly the same answer. Root 6 over 4 minus square root of 2 over 4. And that's square root of 6 minus square root of 2 over 4. Right? So you can use whatever angles you want, and like the formula is correct, right? So cosine of 15 degrees, it has to, or sine of 15 degrees, it has to be sine of 60 degrees minus 45 degrees. And it also has to be sine of 45 degrees minus 30 degrees, right? So it better be the case that either one is going to give you the same answer, right? If they gave you different answers, then the formula would be wrong, right? Because this formula is supposed to be sine of 15 degrees. Sine of 15 degrees is some number. It doesn't matter how you find it. It has to come out to be the same number. Okay, so you can use whichever angles you want, and you're going to end up getting the same answer. Okay, any questions on this example? Okay. Okay, great. So let's do the next one. So we have derive formulas for cosine of 2a and sine of 2a from the addition formulas that we've proven. Okay, so this is not so bad. So again, we'll split it up into two areas. So we have cosine of 2a, and here we have sine of 2a. Okay, so what formula should we use in order to derive cosine of 2a? Well, let's look what we have, right? We want to figure out cosine of 2a. Well, certainly it's going to be one of the cosine formulas that's useful. And well, if we know how to do addition, how do we get 2a? So you can write 2a how? Sorry?
Let's do it by adding.
Right, do it by adding. So we add a plus.
Yeah, balance B and plus B au 15.
Right, exactly. So we use just a plus a, right? So instead this b here, these are just variables, right? We can set them equal to anything that we want, right? So if we look at cosine a plus a, we can use this formula. Just everywhere where we see a b, we substitute an a, right? So I'll say, so cosine of 2a is equal to cosine of a plus a, right? That's the same thing as 2a. It's a plus a. And so now we have our formula. This is cosine of a times cosine of a. And then remember, cosine turns a plus into a minus. So minus sine of a times sine of a. Or if we want to simplify this, this is cosine squared of a minus sine squared of a. Right, so this is one way of writing this formula. For cosine 2a, it's equal to cosine squared of a minus sine squared of a. But sometimes with cosine, you'll see this written in several other ways. So you can write it as cosine squared of a minus sine squared of a. Or what can you do instead? Well, you can
You can
use,
replace.
sorry, yes, yes,
You can use
Gabriel?
the Pythagorean formula
Right.
cos square
Hmm.
a minus plus sin square a equal 1.
Exactly. So using this formula, what do we,
You can solve for cos square.
exactly. So we can solve for cosine. So we could say we get cosine squared a minus sine squared a. And now I can add 1 and I can subtract 1, right? Cosine squared a plus sine squared a, right? When I do this, this is fine because I'm just adding 1 and subtracting 1,
So
right? So if I look at this, what happens? Well, the cosine squared a and the cosine squared a cancel each other out. And
no sin square a.
no, this is fine. We have two different ways of doing this. The sine
Okay,
squareds
okay,
don't cancel each other out here, right? Here the cosines do, right?
okay. Why?
So
Why?
we're left here with, we're going to get a minus sine squared a and a 1 and another minus sine squared a, right? So what we end up with when we simplify this is that this is equal to 1 minus 2 sine squared a,
Yeah, okay. Not
right?
bad.
So this is one formula, or, and what I think Gabriel had in mind, instead of adding 1 and then subtracting 1, well, we can do the same thing, but we can add cosine squared a plus sine squared a and then subtract 1. So we have a third
Yeah.
way of writing this, right? We could say, or we have cosine squared a minus sine squared a, and now we can add cosine squared a plus sine squared a, which, remember, again, is just 1. And then we subtract 1, right? And so if we do that, what's this equal to? Well, now we have that we
Cos
subtract
square
sine
a.
squared a. Exactly. Yep.
Yeah, it will be
Hmm.
2 cos square a minus 1.
Perfect. Right. So 2 cosine squared a minus 1. Exactly. So because the sine squareds cancel each other out, and we're left with 2 cosine squared a minus 1. So we actually have 3 formulas for cosine of 2a, and all of them are valid. And we're actually going to see later today that there are different times when it's useful to use this formula, and there are other times when it's useful to use this formula, and there are times, at least this formula is the easiest one to derive. So it's good to know all 3 formulas here, because all 3 of these are going to be useful in different situations. Okay? So, and this is something that happens a lot in trigonometry, and you especially see this if you're using trigonometry to do calculus, is that lots of times there are lots of different ways of writing the same thing, okay? And underlying that, the reason why there's always so many different ways of writing the same thing is because cosine squared a plus sine squared a is equal to 1. So you can always multiply by cosine squared a plus sine squared a, or you can add it and subtract 1, and it gives you lots of different methods for seeing the
Yeah,
same thing.
how do you got it?
Yeah. All right, so Tony, everybody else is getting me? Tony, it may be on your end, because I think the sound is coming through clear, right? Okay. You're getting me, people? Okay.
I'm getting you. I'm
You're getting
getting
me.
you.
Okay.
Yes, we are
Okay. So
fine.
so Tony, so it's not my problem. Okay. So Tony, yeah, you may need to reconnect. Okay, good. So that's cosine of 2a. And for sine of 2a, we just do the exact same thing. We have sine of a plus a. And using the formula for sine of a plus a, let's remember sine of a plus a, we just do the same formula, but with a every time we see a b instead. Okay. So here, what we're going to have is sine a cosine a plus cosine a sine a. But these are the same thing, so this just comes out to be 2 sine a cosine a. All right. And for sine, this is really the only formula that you use. There's not really any better or simpler way to rewrite this. Okay. So usually we have a lot of symmetry between sine and cosine, but here we have this unusual thing where there's 3 different ways to write the double angle cosine formulas, and there's really only one way to write the double angle sine formula. Okay, so you do get a bit of a difference between the cosine and the sine. And these are called the double angle formulas. Okay. All right, so any questions on either of these?
I think it is okay for me.
Good. Okay. Great. Okay, so let's do the third problem. Can we derive a formula for tangent of a plus b in terms of tangent of a and tangent of b? Okay, so if I want to know tangent of a plus b, well, we don't know yet a formula for tangent. All that we have is formulas for cosine of a plus b and sine of a plus b, right? So, well, we may as well write this in terms of sine and cosine, right? So tangent of a plus b, that's sine of a plus b divided by cosine of a plus b. And I can write out the formulas if I want to. That's going to be sine a cosine b plus cosine a sine b. We mix them up with sine, and then divided by cosine, the plus becomes a minus. So we have cosine a cosine b minus sine a sine b. Okay, so I mean, in one sense, this is the formula for tangent of a plus b. It's sine a cosine b plus cosine a sine b divided by cosine a cosine b minus sine a sine b. But this is maybe not the easiest formula to remember. Okay, it's maybe not the easiest formula to remember. And it would be better if we could somehow write everything in terms of tangent, right? If we could write everything in terms of tangent. Okay. So does anybody see a way that we can take this expression and rewrite it so that instead of involving sines and cosines, it involves tangents instead?
Yeah,
Yes, what do you do?
you can divide by cos A, cos B.
Exactly, right? So what we're going to do is we're going to go divide both the numerator and the denominator by cos A, cos B, right? That's allowed because we're doing the same thing to the numerator and the denominator, right? So we're allowed to divide them. It's like reducing the fraction, right? We're allowed to divide them both by the same thing. So what happens when we do this? We get sine A cos B over cos A cos B plus cosine A sine B over cos A cos B. And then divided by muted unless you're answering a question. So all that same thing divided by cos A cos B divided by cos A cos B minus sine A sine B divided by cos A cos B. Right, all I did was take every single term here and divide it all by cosine of A cosine B. Right, I've got cosine A cosine B in the denominator everywhere, and then these terms in the numerators are the same terms that appear in the original fraction. Okay, so now that we have that, we have lots of cancellation, right? Cosine B cancel out, cosine A cancel out. Here, everything cancels out, and we're just left with 1. And well, over here, nothing cancels out. But when we rewrite this, what do we have? We have sine of A over cosine of A, so that's tangent of A. Here we have sine of B over cosine of B, so that's tangent of B. And then divided by, well, here we just have 1, so that's 1. And then minus, well, here we have sine A sine B over cosine A cosine B. Well, that's sine A over cosine A and sine B over cosine B. So that's just going to be tangent of A and tangent of B. Okay, so Gabriel has exactly the right idea. You divide by cosine A cosine B in both cases. And I think this formula is a little easier to remember than this one. right? I think it looks simpler, and it's nice that it's directly in terms of tangents. So what's tangent of a plus b? Well, it's almost the first thing you would guess if you didn't know anything. It's almost tangent a plus tangent of b, but it's not quite tangent a plus tangent of b. You have to divide by this extra piece. You have to divide by 1 minus tangent a tangent b. Okay. So this is what you this is what you get. Okay. All right. Any questions on this derivation? So by the way, I'll leave this as an exercise. We won't do it, but what do you do for tangent of a minus b? You can just plug in minus b for b everywhere, and this turns out to be tangent of a minus tangent of b divided by 1 plus tangent of a tangent b. Okay. So this is an exercise, but you can get the subtraction formula also. Either you can just do it exactly the same way, or you can just take this formula and substitute minus b for b and realize that tangent is an odd function. So anytime you see tangent of minus b, that's the same thing as minus tangent of b. Okay. Okay. All right, so no questions about this? So I'll box this also. Okay, good. All right, so we've seen a lot of these formulas, so let's move on. Let's talk about some other formulas. So first of all, here we have a nice exercise. Oh, sorry, there's a typo here. I meant to say sine of 20 degrees here. So this is a great question. So we want to show that sine 20 degrees times sine 20 degrees times sine 30 degrees is equal to sine of 10 degrees times sine of 20 degrees times sine of 80 degrees. Okay. And this is a little bit hard because we don't know what sine of 20 degrees is, and we don't know what sine of 10 degrees is, and we don't know what sine of 80 degrees is, right? So, but I claim that knowing what we know about these double angle formulas that we just proved, that we can answer this question without knowing any of those. So first of all, what's the first thing that we can do to simplify this equation?
We can the left hand side.
Right. So what about the left-hand side?
The left hand side.
Yes. What about the left-hand side?
We can multiply and get sine square 20 degree cos 30 degree.
So you want to multiply both sides by
No,
sine. Sorry.
I did it with the left hand side now.
Yep.
The left hand side, if you did it with the left hand side,
Yep.
the sine 20, it can give you sine square 20 degree,
Right.
sine 30 degree.
Okay. Sure. Sure. Okay. So we could say that this is equal to sine squared 20 degrees, sine 30 degrees. But actually,
Then
maybe, yeah.
we can apply the Pythagorean theorem for
Okay,
cos and
sure.
sine.
Right. So this give us 1 minus cosine squared of 20 degrees times sine of 30 degrees. Right.
Yeah.
Yep. So this is okay. I mean, this is true. But, and I guess we know what sine of 30 degrees is, right? It's 1/2. So we can say
Yeah.
this is 1/2 times 1 minus cosine squared of 20 degrees. But I know, to me at least, still not at all clear why it's going to be equal to this on the right-hand side, right? So you may be able to get this to work.
Yeah, but it can still be worked out.
Yeah, it still could work out. Okay, but do you have an idea how to go from here?
Yeah, we can say 1/2
Mm-hmm.
bracket open 1 minus
Right.
parenthesis open.
So you're just multiplying this out, 1/2 minus 1/2 cosine squared 20 degrees. Okay. All right. Well, let's keep this idea around for a little bit. I'm just going to put it over here. I'm not going to erase it. Does anybody see something we can do with the original equation that will immediately simplify it a little bit? Do we see something on both sides of the equation? Right. And well, first, so we've got a sine 20 degrees on both sides of the equation. So why don't we cancel that out? Right. That's just kind of there to distract you. Right. So it's enough to show that sine of 20 degrees times sine of 30 degrees equals sine of 10 degrees times sine of
embargo.
80 degrees, right? Right, because we can cancel out the sine of 20 on both sides. So, or what do we have? We have one half. So we have 1/2.
Yeah, I want to that.
Okay, 1/2 sine of 20 degrees equals sine of 10 degrees, sine of 80 degrees. Okay, you want to give another idea? Well, let me give one more step. I'm just going to move the 1/2 to the other side. I'm going to multiply both sides by 2. So this says that it's good enough to show that sine of 20 degrees equals 2 times sine of 10 degrees times sine of 80 degrees. Okay? So if we can prove this, then we can prove the original identity. Right? We just need to show that sine of 20 degrees equals 2 times sine of 10 degrees times sine of 80 degrees. Now, what is this? Which formula does this maybe remind you of? Something that we talked about earlier today.
Yeah.
Yeah.
Hello.
Hello? Yep. Gabriel?
As I was saying,
Mm-hmm.
if we simplify this, we can read
Yep.
it like the way you wrote it, 1/2 minus 1/2.
Yep.
You open parenthesis, you equals 20
Mm-hmm.
degree,
Right.
all square.
Yep. Oh. Well, but we can't square the whole thing, right?
Yeah,
Because
no, the square only affect the one on the right hand side. So let me
on
see.
the right-hand side.
But because let me I'm proving it.
Okay. So should I erase this last line here?
No.
No, keep that
Later
there.
on,
Okay. Yep.
you can keep it there, and you
Okay.
also rewrite it. You can rewrite it as 1/2,
Okay.
1/2
Mm-hmm.
minus 1/2,
Yep.
parenthesis open,
Mm-hmm.
you equals
Yep.
20 degree all square.
Oh, okay, sure. Okay, that's fine. Okay. Yeah, I mean that's okay.
So then maybe for that we can apply the cos alternative. The sum alternative to cos.
So which cosine identity? Okay, so you want to apply this cosine identity here?
Yeah.
Okay. Okay. So let's see. So what do we have? That says that cosine of 2a equals 2 cosine squared a minus 1. So if we have, so maybe another, so let me just rewrite this. This gives us that cosine squared a is equal to 1 plus cosine of 2a over 2, right? Right, that's what that'll give us, right? So let's see what happens. Sorry,
That was,
yes?
let us use the one with sign. 1 minus
One
2
with sine.
sign.
Okay, okay.
Yeah. Because the end result, any right hand side inside.
Right. So one minus, so you want to write that so this is going to give us, when you simplify it all, it's going to give
1
us
minus
sine
2.
squared a equals 1 minus cosine of 2a over 2, I think.
Yeah.
Is what this is going to give us. Okay. So where do you want to use that here is the question.
What?
Yeah, so where do you want to use that here is the question. So instead of cosine of 20, you want to rewrite this as, well, cosine of 20 could be, you could use, that's like a equals 10 here. So
Yeah,
you could, okay, so you could rewrite it. So you want to use the sign. So you want to say, instead of cosine 20, you want 1 minus 2 sine squared of 10.
yeah.
Okay. Okay, so let's see. So this is going to be equal to 1/2 minus 1/2, 1 minus 2 sine squared of 10 degrees, all squared. Okay. So, all right. So let me, yeah. So,
It will be
let's,
long. It will be long, but I think we can the same result.
okay, well, let's see what happens. I mean, if we do this all out, we're going to get 1/2 minus 1/2, and then we're going to get, I guess,
One,
plus,
parenthesis open.
yeah,
Well,
2
keep a
sine,
parenthesis.
oh, keep the parentheses? Okay.
Yeah.
Okay.
1/2
Yeah.
minus 1/2.
Yeah.
Parenthesis open.
Yeah.
1
Yeah.
minus 4 sine square 10 degree
Mm-hmm.
plus 4 sine to the fourth 10 degree.
Yeah. Okay, so this is all true, but it's not clear to me that we're any closer to proving the equality over here, right?
All right.
So let's, just for a matter of time, let's, this may end up working. But and if you want to work it out after class, then it'll be good to see if you can
Oh,
get this to ultimately work and be equal to the other side, right?
all right.
But for now, if we use this method, I just want to show you that the answer can come very quickly. So sine 20, we want to prove this. Can we write sine of 80 degrees in terms of cosine? So if we want to show that sine of 20 degrees equals 2 sine 10 degrees sine 80 degrees, I can rewrite that as 2 times sine of 10 degrees times cosine of, so we know sine of 80 degrees is cosine of how many degrees, right? Let's remember a triangle, right? If this is 80 degrees, and sine, this is the opposite over the hypotenuse. So how can I express this as cosine of some angle? Well, it's going to be, I mean, I'll tell you, it's cosine of 10 degrees, right? Because this here is 10 degrees, and this same ratio over here is now for the 10-degree angle, it's the adjacent over the, sorry, I didn't mean, I wrote the hypotenuse wrong there, sorry. This should be the, so this should be the hypotenuse, okay? Right, so this is either the opposite or the adjacent, depending on which angle you're talking about. So if you're talking about the 80-degree angle, it's the opposite over the hypotenuse, that's sine of 80. But if you're talking about the 10-degree angle, it's the adjacent over the hypotenuse, so that's cosine of 10. So sine of 80 degrees is cosine of 10, and this we know is true. And it's true because of the double angle formula for sine. Okay. So if you really want to do it as a proof, you can kind of work your way backwards here, right? You can say you start with sine of 20 degrees equals 2 sine of 10 degrees cosine of 10 degrees. That's true by the double angle formula. Then you go backwards and you say cosine of 10 degrees equals sine of 80 degrees. Then you divide both sides by 2. We're just reversing each step. So you get that 1/2 sine 20 degrees equals sine 10 sine 80. Then you just observe that 1/2 is equal to sine of 30 degrees. So sine 20 sine 30 equals sine 10 sine 80. And then lastly, you multiply both sides by sine of 20 degrees in order to get back the original results. Okay. So we have somehow we basically did the proof in reverse, but the quickest way I think to this proof is you get rid of the sine of 20 degrees, and then you evaluate sine of 30 degrees, move it to the other side, and then with a little change you can apply this double angle formula. So it's kind of a, it's a difficult problem, and it's not something you'd expect by looking at it, but in fact these, sine 20, sine 20, sine 30 is the same as sine 10, sine 20, sine 80. Okay? So and you can verify that on a calculator if you want. Okay? So ultimately it comes down to this double angle formula for sine, using that sine 20 equals 2 sine 10 times cosine 10. Now, it may be easier, or it may be easy enough to get this to work, but I don't know exactly how to work it. But I encourage you to fiddle around with it, and maybe eventually you can simplify this and it'll work. Okay. All right. Any questions on this? Okay. All right. So let's move on. Let's do the half angle formulas. So how are we going to get a formula for cosine of theta over 2? Well, in this case, let me just recall that we have these double angle formulas, right? So these double angle formulas say that cosine of 2a is given, and I'm going to use these two formulas down here are going to be the more useful one. So it's 1 minus 2 sine squared a, or 2 cosine squared a minus 1. So cosine of 2a, I'm just going to rewrite that. So cosine of 2a is equal to 1 minus 2 sine squared of a, and it's also equal to 2 cosine squared of a minus 1. Okay. So if we want to derive a formula for theta over 2, cosine of theta over 2, what we have to do is just make a substitution. We make a substitution. What substitution do we use? Well, I'm going to write the substitution a equals theta over 2. Right? So we can plug in theta over 2 to both sides of this formula. So then if I have cosine of 2a equals 2 cosine squared a minus 1, which I know, well then the substitution, this becomes cosine of 2 times theta over 2 equals 2 cosine squared of theta over 2 minus 1. Right? I'm just doing the substitution. And now this simplifies. This gives us that cosine of theta is equal to 2 cosine squared of theta over 2 minus 1. And we want a formula for cosine theta over 2, so let's isolate it, right? So this tells us that 1 plus cosine of theta is equal to 2 cosine squared theta over 2. Just added 1 to both sides. And now I'll divide both sides by 2. So 1 plus cosine of theta over 2 is equal to cosine squared of theta over 2. And so what does that tell us in the end? We get that cosine of theta over 2. Well, it's the square root over here, so we have to take the square root over here, but we also have to allow it to be either the positive or the negative square root, depending on what the angle is. Right? So cosine of theta over 2 is going to be the square root of 1 plus cosine of theta divided by 2. Okay, and this is going to be our formula for cosine of theta over 2. Okay. And I should add, sorry, plus or minus. Okay, so you can get the half angle formula by starting with the double angle formula and then making a substitution where a becomes theta over 2. And in that case, what happens is the 2a becomes theta, and the a becomes theta over 2, and you end up getting a formula for cosine of theta over 2 in terms of cosine of theta. Let's write that down. Right. And so let me just rewrite this so it's a little neater. Square root of 1 plus cosine of theta divided by 2. Okay, and this is what's called the half angle formula. Right.
Yeah,
Okay, is that okay?
yes, sir.
Yes, Prince?
Yeah, thank you for this demonstration. Very admire it. But my concern has been due to what we have cos theta equal to 2 cos square. I want to say be theta over 2 minus 1. Why you decided to just take this minus 1 and carry across?
Well, okay, so this is just the formula that we have. I'm just copying this formula from the earlier page, right? This is just the formula that we derived for cosine of 2a. It's 2 cosine squared a minus 1. Okay, this is the formula that we did earlier on in the homework. So if we know this formula and we carry it across, then all that I'm doing is substituting theta over 2 for a. So if I have this minus 1 over here, nothing's happening to that minus 1, right? It's just theta over 2. All I'm doing is replacing every a I see with a theta over 2. So that's going to make this formula okay. I still have this minus 1, and ultimately, this minus 1 over here becomes the plus 1 over here, which becomes the plus 1 in the final formula. So that's why we get this plus 1 over there.
So yes, yes. So what I'm saying is that
Mhm.
because we don't have any numerator, so we carry the minus 1 across to meet whatsoever, or it's just because the formula has to be 1 plus cosine theta. Is that why we carry the 1 across to become plus?
Well, yeah, right. I'm carrying it across because the question is
Yeah.
saying I want a formula for cosine of theta over 2. And so ultimately I need to isolate cosine of theta over 2. And part of that isolation is carrying this minus 1 across. Gabriel?
Yeah, but man, your focus is to solve for cos 2, or your focus is to solve for cos theta over 2.
Yeah.
So in order to solve for cos theta over 2, you have to isolate the 1, send 1 across.
Right.
A change of subject.
Yeah, I'm okay. Cos theta over 3 is going to be a harder formula. I don't know how to do that from here. But
No, I'm saying
yeah.
the question I'm asking, why you sending 1 across? You sending 1 across because you want to make cos theta over 2 the subject.
Right.
Mm-hmm. So the reason you send it across, so that in I think that's only I'm not sure you understand.
Right. So Prince, do you still have the question? Right. The point is we're trying to get cos theta over 2 by itself. That's why we have to send the 1 across. Is that okay?
Okay. 2 cos square, parenthesis of theta over 2. So
right, exactly.
What did we do here for how to get rid of this square? Did you introduce a square root here?
Yeah, I use the square root, right? So this is the So here we have this equation, and now all that I did here was take the square root of both sides, right? So here I'm taking a square root of both sides, right?
That is the rules.
That's how I get rid of a square, right? So the cosine squared of theta over 2 becomes just cosine theta over 2. And here I get a square root, but I have to do plus or minus because I don't know if it's the positive square root or the negative square root. So I have to allow both plus or minus square root. And something to keep in mind is this 1 plus cosine theta in here is always positive or 0. So we're never taking the square root of a negative number, right? So this formula is fine. It's going to be a nice real number that you get from taking this square root because this numerator here, 1 plus cos theta, is always going to be at least 0. So you're never going to have something negative under the square root. But after you take the square root, you might need to put on a plus or a minus, depending on whether you know cosine of theta over 2. You can know by looking at the angle whether the answer is supposed to be positive or negative. So like if theta is 90 degrees, then theta over 2 is 45 degrees. You know the answer has to be positive. So you'll use the positive square root. If theta is like 300 degrees, then theta over 2 is 150 degrees. We know that cosine theta over 2 is negative at 150 degrees. That means we'd have to use the negative square root here. Okay, so you have to use your judgment for plus or minus here based on what what you know the sign of the answer is going to be, whether it's going to be positive or negative.
Okay, thank you, sir. Thank
Okay.
you.
All right. You're welcome. Okay, so let me just do quickly the same formula for sine of theta over 2. We're going to do the same thing, except we're going to use the other formula for cosine of 2a. So for sine of theta over 2, we're going to use that cosine of 2a is equal to 1 minus 2 sine squared a. Okay, this is, again, just the formula that we took from this homework exercise. I'm just using the other formula, the 1 minus 2 sine squared a, instead of 2 cosine squared a minus 1. Okay. All right, and so now we do the same thing. We're going to substitute a equals theta over 2. And that's going to give us cosine of 2 times theta over 2 is equal to 1 minus 2 sine squared theta over 2. That's the same thing as cosine of theta equals 1 minus 2 sine squared theta over 2, which is the same thing as, I can say 2 sine squared theta over 2 plus cosine theta equals 1. Just move the 2 sine squared theta over 2 to the other side. And that's the same thing as sine squared theta over 2. Well, maybe I'll subtract the cosine theta first. So that's the same thing as 2 sine squared theta over 2 equals 1 minus cosine theta. And that's the same thing as sine squared theta over 2 equals 1 minus cosine theta, all divided by 2. And now we want sine of theta over 2, so at the last step, we take the square root again, right? And we have to throw on a plus and a minus. So we again take the square root, and this is going to give us that sine of theta over 2 is equal to plus or minus square root of 1 minus cosine theta over 2. Oh, maybe a package or something? Oh, the sprinkler people are here. Oh, yeah. Yeah, can you? Great. Thanks. Sorry, and if they need to talk longer, I can go. Sorry. No. Okay. Okay. All right. So we get similar formula, just with a 1 minus cosine theta instead of a 1 plus cosine theta. Okay. And then tangent, I'll just write that tangent of theta over 2 is equal to sine of theta over 2 divided by cosine of theta over 2. And that's equal to square root of 1 minus cosine theta over 2 divided by square root of 1 plus cosine theta over 2. These are the two formulas that we have. And this is equal to the square root of 1 minus cosine theta over 2 divided by 1 plus cosine theta over 2. And now we can multiply both of these by 2, and we can get this slightly simplified form that this is the square root. I mean, these are all plus or minuses, so we're always going to have plus or minus. So plus or minus, it's going to be 1 minus cosine of theta divided by 1 plus cosine of theta. Okay, so this is the formula for tangent of theta over 2. Okay, you just get it by combining the sine formula with the cosine formula. So sine theta over 2 divided by cosine theta over 2. And then eventually, when you simplify, the 2's go away, and you're left with 1 minus cosine theta over 1 plus cosine theta. Okay. All right, so these are all of our half angle formulas. We have cosine theta over 2. And next time, I'm going to summarize all of the formulas. So we're going to begin the class next week. I'm going to summarize all the formulas. But for today, we have a formula for cosine theta over 2, a formula for sine theta over 2, and a formula for tangent of theta over 2. So let's test this with an example. So let's recalculate, what do I want to say? Okay, so let's recalculate cosine 15 and sine of 15 using the half angle formulas. Okay, so cosine of 15 degrees, well, that's the same thing as cosine of 1/2 of 30 degrees. And so by the half angle formula, that's going to be square root. We know it's going to be positive, so I don't have to write minus, of 1 plus cosine of 30 degrees over 2, right? And that's equal to the square root of 1 plus, well, cosine 30 degrees is square root of 3 over 2 over 2, right? Or another way of writing this is we're going to have, so square root of 1 plus square root of 3 over 2 over 2. So we can simplify this fraction. This is going to be the square root of, we can get a common denominator that's going to be 2 plus square root of 3 over 2 over 2, right? Because 1 plus root 3 over 2 is 2 plus root 3 all divided by 2. And this is equal to the square root of 2 plus square root of 3 over 4. And this is equal to the square root of 2 plus square root of 3 divided by 2, if you want to see this. So maybe we'll only do cosine. I'm going to leave the other one as an exercise because I want to give a... So, I mean, this is the answer that we get, right? So that's not so fantastic, right? Because the old answer we got... What was the old answer that we got? The old answer that we had was, for cosine of 15 degrees, was square root of 2 plus square root of 6 divided by 4, right? So the old answer that we had was square root of 2 plus square root of 6 divided by 4, right? So these don't look so much like each other, right? I mean, this is kind of a problem, right? We have completely different answers here, but they're both supposed to be cosine of 15 degrees. So what we're going to need to do actually is we're going to need to check. So a question, is square root of 2 plus square root of 3 over 2 equal to square root of 2 plus square root of 6 over 4, right? Seems not necessarily true. Well, let's see, right? Maybe they're just two different ways of writing the same thing. Well, so let's see. Let's see what happens if we square both sides. Okay. If we square both sides, on the left-hand side, we get 2 plus square root of 3 divided by 4, right? Because squaring it, we multiply, we get rid of the outer square root, and this becomes 4. And on this side, the right-hand side, we get what? We get root 2 plus root 6 divided by 4 all squared. So we're going to get over 16. Root 2 plus root 6 is going to be what? That's going to be 2 plus 6 plus 2 times root 2 times root 6 divided by 16. Or in other words, this is going to be, 2 root 2 root 6 over 16. Or in other words, this is 8 plus 2 times square root of 12 divided by 16. Okay? But what is this? Well, if we divide this by 4 over 4, in the denominator we get 4. Well, okay, maybe I'll write one extra step. This is 8 plus 2 square root of 12 over 16, which is the same thing as 8 plus 4 square root of 3 over 16. Right? Because square root of 12 is equal to 2 square root of 3. So we have 8 plus 4 root 3 over 16. And if we cancel out a factor of 4 on both sides, we end up getting that this is 2 plus square root of 3 divided by 4. And so it turns out that these two things are equal. Okay, so even though these two numbers don't look the same, they're actually equal to each other, because we proved that if I took the square of both of them, then we got equal numbers. The square of this is 2 plus root 3 over 4, and the square of this, when you simplify it out, it becomes 2 plus square root of 3 over 4. So these two answers for cosine of 15, they look like different numbers, but in fact, they're both exactly the same number. And you can do this if you want to check with a calculator. You can show that both of these are basically 0.956. Okay. Okay.
Great.
All right. So this is,
Yeah,
so
so
you have to be
hello.
careful with these square roots that things can look different, but really be the same. Yes, question? Emmanuel.
Yeah, no, I got it. It's okay.
Oh, okay, good.
The 15,
Yeah,
it was 30 divided by 2. Now you got it 15. Okay.
exactly.
Yeah, thank you. I got it.
Yeah, so that's what we have here, cosine of 1/2 times 30 degrees. So here, what's being used is the half angle formula. Okay, so maybe I'm going to leave sine of 15 degrees as an exercise. Okay, so I'll leave sine of 15 degrees as an exercise, but the point is you can do it with the half angle formula. It's just going to be the same thing. There's just going to be a minus here instead of a plus. And you're going to get an answer. It's going to be the same as this answer, just with a minus instead of a plus. And then you want to compare it to what we got for sine of 15 earlier on, which was square root 6 minus square root 2 divided by 4. And you want to see that this expression is actually the same as that sine expression. And you can do it exactly the same way we did this here. Okay. So I have one more slide. So let me just do this one slide kind of quickly for time, and then there's some homework and I'll talk about next week. So how would we derive a formula for cosine of 3 theta? Or I can use whatever letter I want, maybe cosine of 3a, just because it's easier to write a. It's the same thing. Well, I can do that cosine of 3a is equal to cosine of 2a plus a. Exactly, right? And so this is going to be cosine of 2a times cosine of a minus, right, sine of 2a sine of a, right? And so now we have to use the formulas for sine and cosine. So for cosine of 2a, we can use whichever formula we want. Maybe I'll just do the first one. So this is cosine squared a minus sine squared a, all times cosine a. Right, remember, this is our original formula for cosine of 2a. And then minus, right, 2 sine a cosine a
Cosine A times
sine a. Exactly. And we'll remember over here, this was sine of 2a. So let me just simplify this a little bit. So this is going to be cosine cubed a, cosine squared a cosine a, minus sine squared a cosine a, and then minus 2 sine squared a cosine a. And so these terms are the same, so we end up getting cosine cubed a minus 3 sine squared a cosine a. So this is one formula for cosine of 3a, and you can find other equivalent formulas if you use different versions of the cosine 2a identity. So I won't write the other ones down, but you can do it if you want to, and you can get other equivalent versions of this formula. So again, I don't expect you to memorize this formula, but it's good to know that if you need to know a formula for cosine 3a, you can get it by using this process. And if you need a formula for cosine of 4a, then you can get it by doing cosine of 3a plus a, or cosine of 2a plus 2a. And in any case, you can just keep using these addition formulas over and over again to get formulas for whatever you want. Cosine of 3a, 4a, 5a, anything you want. You can just keep repeating this process. Okay? So, but this is a formula for cosine of 3a. It's cosine cubed a minus 3 sine squared a cosine of a. And if you want to get it completely in terms of cosine, you can. But I won't do that right now. Okay? Maybe I will. Okay, we have 2 minutes. Let me do this. Let me just say, or if I use that sine squared a equals 1 minus cosine squared a, I use this Pythagorean theorem. So in that case, we get cosine cubed a minus 3, 1 minus cosine squared a, cosine a, right? I'm just using this as a substitute for sine squared a. And that's going to be cosine cubed a minus 3 plus 3 cosine, 3 minus, I'll call this 3 cosine a. That's what I get when I do the 3 and the 1 and the cosine a. And now if I do the minus 3 and the minus cosine squared a and the cosine a, I get plus 3 cosine cubed a. So plus 3 cosine cubed a, and that comes out to be 4 cosine cubed a minus 3 cosine a. So this turns out to be another equivalent formula for cosine of 3a. Okay, so either one of these is okay, right? Both formulas are valid. Okay. All right, so you can do cosine 3a. So for homework, so first question is to calculate tangent of 7 pi over 12. You may have to use a half angle formula here, or maybe an addition formula for tangent, or a subtraction formula for tangent. Number 2 is to derive a formula for sine of 3 theta, similarly to how we derive the formula for cosine of 3 theta, and then verify your formula for theta equals pi over 6. So, plug in 30 degrees to your formula and show that the answer that you get is sine of 90 degrees, that it gives you 1. And then 3 is, can you use the formulas on page 5 of the handout to derive a formula for cosine of a cosine of b? So page 5 of the handout, remember, is over here. So if you can look at all these formulas, and the question is, can you use those formulas to derive a formula for cosine a cosine b? And if you can, try to verify your formula when a is 30 degrees and b is 60 degrees. Okay, so these are the homework. I'll send out the notes later today, like I always do. And so thank you as always for your attention. So we will meet next week, no more long breaks. And we're done with the formulas now. We'll review all the formulas next time. And then we're gonna discuss applications of trigonometry to non-right triangles. So we're gonna talk about the law of sines and the law of cosines and how you use trigonometry with triangles that are not right-angled triangles. Okay, so thank you so much. Are there any questions?
Thank you. Thank you.
All right, you're welcome. I'm gonna stop the recording.